welcome to another edition of ICANN Media TV. I'm your host, Rob Hislop. On our last show, we had the pleasure of speaking with a scientist from Zurich, Switzerland, who is using a modified sponge to try to pick up oil spills. At least that's the ultimate goal. On today's show, we're going to be talking to another scientist who has been working on his own idea on how to clean up oil spills. A little bit different, though. While this guy works for Fermilab, he actually is working on his oil spill technology in his own garage. Arden Warner joins us now via Skype from Batavia, Illinois. Arden, tell us exactly what prompted you to think that perhaps you could come up with something to deal with oil spills.
Well, I was watching the coverage of the disaster here, and my wife essentially asked me, after some frustration from me, that, what would I do to solve the problem?
And of course, when you mention disaster, Arden, you're talking about the BP Gulf of Mexico oil spill.
The Gulf oil spill, yeah. And I said to her, well, I think I would try to magnetize it. And that was something I said. But then later that evening, I thought about it and said, that's not a bad idea. So I came up with a concept of how to do this. So I went into my garage and I tried to get some small shavings from my shovel by literally filing them off. And I put them in some engine oil, and it worked at a rudimentary level. And then I decided to get more scientific about it and get really small particles that would be buoyant, or at least make them very hydrophobic so that they would go into the oil. And then I started to pull them around with a rail magnet. I measured the field and then got salt water and started to make experiments.
Arden, I can only imagine a lot of people were glued to their television sets watching the developments of the BP Gulf of Mexico spill. It's unlikely, though, that very many of them sat there thinking, hey, you know what? I can fix this. And not only that, I can probably do it in my spare time in my garage.
Yeah, initially I started to just go at it at home. I tried over 100 different types of oils and different size particles. And then I got the lab involved because there was a call for anyone who could help with an idea that could help to do what you could. So I got more scientific about it, and I started to measure the particle sizes and try to document what it was doing. And it started to work even better when I got the right size particles and the right magnets. So I then decided to get crude oil, different samples, and try it. And I tried it on most oils, and it worked.
Okay, perhaps now you can tell us a little bit about your process. From the videos that you sent us, it looks like sometimes you sprinkle some iron filings on droplets in water. Other times you completely cover a droplet that was, I believe, on a countertop.
Yeah, and what I did, I tried to figure out, at least in the experiments, whether or not what's the ratio of stuff I needed. So I started to put very, very little, small amounts of particles in. And then I even tried an experiment. I think you might have seen the video where I didn't put it in the oil. I just sprinkled it in the vicinity, and it, and then use a magnetic force to pull it, and it gets into the oil and it pulls the oil. The oil starts to come together from the magnetic force, and the fact that the oil forms sort of a bond with the oil rather than the water.
It's quite fascinating to watch, Arden, because from looking at your experiment, you can see that you don't really need that many iron filings, and you're still able to pull, granted a mini spill, but you're able to pull it throughout the entire tub that you're using. Do you think that this is something that's transferable to larger scale operations, say in an ocean or large open water?
Yeah, we tried to scale it up, and we are about ready to do some larger scale experiments. But the principle is the same principle. The thing you would worry about in the ocean would be wave action, and typically wave action doesn't disperse a spill. It creates large plumes, and magnetic forces don't change as a result of being out in the ocean. So everything is the same, except that you would have the wind and various elements to contend with. But the principle itself should work. So we will test that. We've tested it on larger scales, and it does work.
Now, I believe I read this in one of the news releases that came out about the work that you're doing. And it's not only that you're hoping your process can clean up oil spills, but you think it also may be able to be used to help animals who are in distress as a result of being covered in the oil.
Yeah, one of the things I did, and I tried this heavy oils, after a few days, it gets very heavy and thick and black. I tried this on bird feathers and other surfaces, and I was able to use a magnet to remove it. I even got word from some scientists in another facility in Australia that they've been trying something like this for a long time, and they sent me some results, and it does indeed work.
Well, I'm just wondering now, because much of the oil from an oil spill actually ends up going to the bottom of the ocean, lake, river, etc. What can your process do for that? Or is that something that you can actually work at?
Yeah, well, the size particles I had worked well for surface oil. But one of the things I learned and I noticed, sort of serendipitous, is that when I started the experiment, some of the filings were randomly sized. And some of them that were heavy literally went down into the water, and they lodged themselves in oil that was at the bottom, that was heavier. And when I pulled with a magnet, this stuff actually came up. So then I started to investigate the buoyancy and the size of the particles more accurately, and I find I can size the particles to go down and actually pull oil up from the bottom.
What about concerns about putting iron filings in water? I mean, it's one thing you've got the pollution, now you're sticking another foreign element into the water as well.
I think in open water, we need to design a system that allows us to get very close to the surface of the oil and literally drop this stuff rather than drop it from the air. You want to be able to minimize the wind effects and so on. So something will have to be mechanically designed to distribute the particles. But in either case, if you're in a large open ocean situation, I don't think dispersing the particles into the oil, since you need it to be in the oil per se, as I demonstrated, shouldn't be a difficult engineering task to achieve. I mean, we should be able to inject these particles in a relatively large area without getting too much of the stuff airborne.
Arden, what type of magnet do you think you would need to attract the iron filings and then pull them and the oil out of the water?
Yeah, well, on a rail system deployed, I would use an electromagnet, because then you can control the field. I use a permanent magnet in a lot of the tests, and in some cases, a permanent magnet would work. But in a real open system, if I develop this into a larger system, I would use something where I could actually increase the current and increase the field strength. And but the efficiencies need to be measured. Maybe there's some field that is ideal in certain conditions, and that may be enough.
Thank you so much for your time, Arden.
All right, thank you.